Okay, here we go. So the answers to the Unit 4 practice test. Number 1, this substance consists of 2 or more elements in a fixed mass ratio, as if we were to say like a 1 to 2 or 1 to 3 or whatever. Atoms always combining in the same ratios. That's going to be B, a compound for number 1. Number 2, this substance cannot be broken down by physical or chemical means. So we can break mixtures down by physical, we can break compounds down by chemical. We cannot break down elements any further than they are already broken down. So number 2 is A. Number 3, the composition of this substance is variable. Its physical properties depend on the composition. There we're talking about a mixture. So 3 is C. Number 4. So electrolysis can be used to separate this substance. This is talking about decomposition, breaking something down by chemical means. This is what we have to do is if we want to separate a compound down into its smaller parts, that has to be by a chemical separation technique such as electrolysis, like separating water down into H2 and O2. So that is going to be B for number 4. And number 5 is going to be C. Homogeneous means same composition throughout. So you really can't tell the different parts. Hetero means different. So that means different parts of the mixture have different makeup. Okay? Everybody good with that? Cool. All right, so on to the back side. Number 6, a mixture of molecules. So molecules are going to be when we have more than one atom stuck together. That looks like this would be one type of molecule. It's actually an element here. And this is a different type. So we have more than one type of particle that makes a mixture, right? So we try to distinguish between pure substances and mixtures. Pure substances, each piece is the same. Each particle is the same. Mixture has more than one type of particle. So this would be a mixture of compounds, or of molecules, sorry. 7, atoms of a pure metal. This is pure, all the same atoms stuck together as a solid. This is going to be a metal. Molecules of an element. So if it's an element, means it only has one type of atom. Not talking about particles, atoms. So that means all the atoms have to be the same. So C looks like that would definitely be an element. But what we're looking for is the molecules like this. That's going to be F for number 8. Number 9, a solid compound. So compounds are also pure substances, but more than one type of atom. That's going to be A. And number 10, a mixture of elements. So this piece has all the same atoms. That's an element. This is just one atom, so that's an element. Same element there. Another element. So that's a mixture of elements. 10 is E. Okay, for number 11, if you remember when we did the phase change diagrams, one of the things that we learned when we talked about phase changes is that the temperature does not change during a phase change. So we could look at flat parts and we could say, hey, there's a phase change. Maybe that's freezing or melting or boiling or condensing or whatever. So here we're just talking about the BP. I probably should have made mention that stands for boiling point. Okay, so we've got the boiling point of methanol. We've got the boiling point of ethanol. Methanol is at 65 degrees. Ethanol is at 78 degrees. Can I erase all this stuff up here? So what I'm going to do is I'm just going to take one 65 degrees. So here's the temperature. So in between is 70. So maybe in between there, somewhere like here, I would make a flat spot. Okay, and then a little higher, like right below 78, I make another flat spot. Maybe I make it a dotted line, or maybe I just label my lines. And so we're heating this substance up. So originally it was a lower temperature. Maybe they're going up to the same point. So this would be ethanol here. This would be methanol here. They could continue on up, whatever. Okay. The main idea, though, is just the flat spot shows the boiling point. So one's at 65 and the other is at 78. So how could you use this information in the graph do you sketch for question 11 to separate a mixture of methanol and ethanol? So with a mixture, we can separate those by physical separation techniques. When we're talking about boiling point, the separation technique is called distillation. This was in your review. And so what I would do here is I would just heat the substance carefully, maybe heat it to about 70 degrees Celsius. And at 70 degrees Celsius, the methanol would boil off, leaving ethanol. Okay, so that's distillation. We talked about some of the different separation techniques, filtering based on size. We could also talk about solubility. If something dissolves in something, that can be another way to separate things. We talked about magnetism being used if we're trying to separate something that's magnetic, like iron. And what else do we say? Distillation right here, based on boiling point. Question about distillation. So another example I gave was salt water. So salt and water, it's a mixture. They have different boiling points, right? If I heat it to 100 degrees Celsius, the boiling point of water, the water will all boil off. The salt won't, though. So if I boil all the water off, I'll be left with just salt. I have now separated the salt from the water. And technically with distillation, we would also collect the substance that's being boiled off. The main idea is to know that distillation is based on the boiling point of different substances. That will be what you're asked on the test. We all set with this? All right, so it says sketch a particle diagram representing a mixture of hydrogen and oxygen gases. Sketch a particle diagram for the compound formed when these gases react. Describe how these diagrams are different. I'm more concerned with you just making the diagrams. So I'm going to use black dots to represent hydrogen. I'm going to use white dots to represent oxygen. So if I have a mixture of hydrogen and oxygen gases, I could just do something like this. The problem is we actually know now that hydrogen and oxygen are diatomic elements, right? So they actually exist as two atoms stuck together. Diatomic elements, that's what diatomic elements are. And so in the compound, I could just, what do hydrogen and oxygen form when we combine them? H2O. So I could do this. Oops, I did them backwards. And I'm all set. Now you might be looking at this saying, if these are gases though, this wouldn't follow Avogadro's hypothesis. Which means if we have equal volumes of gases at the same temperature and pressure, which is important, we should have the same number of particles. This first picture has 3 particles. This has 2. This is going to lead us into the next part, though. All right. One volume of gas A combined with 2 volumes of gas B to form 1 volume of product when measured at the same pressure and temperature. Sketch particle diagrams for molecules of gas A, gas B, and the product. So here we're going to do kind of the same thing. And it says gases A and B are monatomic. So we don't really know what gas A is or gas B. So maybe I'll just do something like a couple dots in this one, maybe a couple dots in this one. But I should make the same number of dots in each one, right? So if I just combine one of each, I get this, I get this. And to check Avogadro's hypothesis, each box should have 2 particles. So 2 particles, 2 particles, 2 particles, and 2 pieces here, 2 particles. So we are following Avogadro's hypothesis. Number 15, if the gases in question 14 were diatomic, excuse me, were diatomic, how many volumes of product would be made? That means these would be double the dots, okay? And so in order to follow Avogadro's hypothesis where we have the same number of particles in each box, I would need to have another volume, okay? So I would make 2 volumes of product. I'm going to go ahead and pause there, and then I'm going to add the last question on the video next hour, so it will be on the video if you want to check it, which I highly recommend looking at these videos tonight and go over the last few days. Okay, so this is one of those problems for multiple proportions. It says we are determining the mass of the value of the ratio here, mass N to mass O. It's important to pay attention to what's on top. Okay, so the element on top is nitrogen. So when I divide these, I'm going to put nitrogen on top. So I'm going to go 63.6 divided by 36.4, and that comes out to be 1.75. In B, I'm going to have 46.7 divided by 53.3, and I get 0.88. Okay, so when we do these multiple proportions problems that have the two compounds with mass ratios, what you want to always do is take the larger one and divide it by the smaller one so that I can see how much bigger one is than the other. So if I take 1.75 and I divide it by 0.88, it comes out to be 1.98888. So it's pretty close to 2. So A is 2 times larger. And now I said pay attention to which one's on top, nitrogen. So really what it's saying is A has 2 times more nitrogen. So when I sketch them for part C, A and B, I'm going to make the one that has less nitrogen just have one atom. So 1 nitrogen and 1 oxygen. So that's, I'm making green dot be nitrogen and white dot be oxygen. Okay? And the formula for that would be 1N, 1O. Over here for compound A, I know that compound A should have 2 times as much, so I'm going to make 2 nitrogens stuck to 1 oxygen, and that would be N. There are 2 of them, and still 1O.